also honored to have Mr. Shailesh B. Modi, Senior Manager and Group Head, ERDA. Today, Mr. Modi will talk about role of virtual inertia in future grid having predominant contribution of renewable energy integration. So, let's welcome Mr. Modi.
We know that presently the renewable energy integration with respect to a solar PV system or wind system is continuously increasing. This is required to meet a high energy demand and of course to sustain a green energy environment. We can say steps towards zero emissions. And the government of India also encourage the energy production, power production from the renewable energy sources. As far as the present power scenario of India is concerned, in India it is already crossed this installed capacity of 440 gigawatt, and from that presently 33 about 33% power generation is from the renewable energy like solar PV and wind generation and other, and about 10.5% power generation is from the hydropower plants. If we think on the future, and it will this power requirement will goes up to 800 gigawatt by 2030, and our government of India has made a target of 500 gigawatt from renewable energy itself. At 2030, that is 2030, this contribution of renewable power generation will cross 50% of the total power generations. So now, because renewable power generators, they do not contribute for the inertia response. That is, we can say that the stability, frequency stability issues will be there whenever there is a dominant generation from the renewable power sources. So this is the topic that future system operator, researcher, policy maker will have to think of how to tackle this issue of the inertia, because whenever in future there will be a dominated generations which will be based on the power electronics devices like inverter based generators, which will not contribute much on this inertia response, then how we can achieve our frequency response or stability of frequency, that is the concern in the future power grid. Now presently this frequency and active power control is managed by our conventional synchronous generation. AGC, automatic generation control, take care for the variation in the demand and frequency. For example, whenever there is a increment in the demand, frequency of the system will go down, and automatic generation control, that is AGC, will produce a signal to increase the input mechanical energy, which will increase the speed of prime mover and of course the synchronous machine, and this is how bring back the uh, frequency up to the original value. Similarly, whenever there is a decrease in the output power, decrease in the power, active power, there will be increment in the frequency, and again AGC will take care for the control of the frequency. This is the condition for the steady state power condition. Now, as far as the instantaneous change in the demand or some abnormal condition for a short duration of time, then kinetic energy stored in the our synchronous machine will take care to maintain the frequency for a short duration of time. Now, when imbalance happen, the inertia of the system resists the change to the electrical frequency. Now, as the amount of inertia reduces in the system, the rate at which the frequency deviates become larger. In future grid, there will total inertia in the system will be very less, because in the future grid will be the inverter dominated grid. So this is the issue, how we can manage the issue of low inertia and to maintain the frequency at the constant level. We know that variable speed wind turbine are the back-to-back converter, and PV system are DC to DC converter, and they feed supply to the grid through the inverter. And this inverter is not participating any inertia response. So now in future, whenever there is a high integration of renewable energy into the grid, so we will be able to meet the power demand in the future, but there will be a inadequate level of the inertia generation by the renewable sources. Another issue as far as the inertia is concerned, so protection related issue, because whenever there is a change or decrease in the system inertia, there will be increment in the rate of change of frequency, that is ROCOF. This is very important parameter for the power system as far as the frequency stability is concerned. And this low frequency nadir point will also go down in a very short time duration. Now, as a result, there may be a tripping of the relay causing a under frequency load shedding, and there may be a loss of production and outage of the systems. Hence, additional inertia will be required in future grid. Now, what is virtual inertia? Basically, it's a control algorithm. This virtual inertia algorithm take a feedback from the power grid of the power system parameters like active power, frequency, voltage magnitude, and phase angle depends on the control strategies, and produce a get signal, and it gives a getting signal to the input of the variable energy sources, that is the renewable energy, and accordingly renewable energy changes the input power to the inverter, and this is how this output of the inverter, that is V particular for the frequency, it will maintain the constant frequency. So this control algorithm is take the data from the grid and provide a input signal to change the input to the inverter. So this is the one of the solution to provide a virtual algorithm, or we can say the synthetic inertia. There are various strategies to control the frequency through a virtual algorithm. So it is essential to optimize the effectiveness in managing the modern power system. There are various frequency control strategies, and based on the requirement and based on the power system characteristics and requirement, we can, or system operator or utility or a project developer can decide a suitable control strategy to optimize the effectiveness in modern power systems. So this is one of the solution, how we can take the challenges for the decrease in the inertia in the future grid. This is how it will enhance the overall efficiency, reliability, and resiliencies of low inertia grids. These are the some of the control techniques like adaptive control. For example, in case of grid forming inverter, we can use a group control to maintain the frequency as a constant. It is used in a grid forming inverter also. Neural network. Similarly, whenever there is a variability or uncertainty is there in the renewable energy sources, we can also think of on the predictive controls like model predictive controls, fuzzy logic controls, and proportional integrative derivative controls. Similarly, there is a various topologies for the control of virtual inertias like synchro inverter, swing equation based topology, or virtual synchronous based topology. Now, The application of these various topologies and control strategies depends on the behavior and characteristics of our grid. It also depends on the existing synchronous generator available in the system and amount of renewable power integration into the grid. Now, for example, if we require only a frequency dynamic control, then virtual synchronous generator is most suitable because it because there is a it is a this system is used for the application of the control of the dynamic frequency variations, not the entire behavior of the synchronous generator. So one of the challenge for the future grid will be the inertia estimation techniques because actual accurate estimation is required for the steady power system operation by the system operator. And we know that uh, there will be data forecast data available for the PV system and wind power system. This data, of course, will be helpful for the system operator to calculate the inertia in the grid. But the availability of the renewable sources is not a certain. There is a not certainty for the availability of this renewable system into the grid because it depends on the renewable sources. Now, under these circumstances, this technology use of and role of the technology will be there, like a wide area measurement system and phasor measurement units. Now utility is going to install PMU in the transmission system. Because warm system and PMU gives the data very fast compared to the other system, and for measurement of frequency events and precise measurement of rate of change of frequency, that is the ROCOF, will be quite useful for the system operator to estimate the inertia in the system. So use of this technology will be more in future grid also. Now, based on this, now another thing I want to say that the loads, that is demand side management, loads are also contributing to the system inertia. Like heavy motors or industrial motors are also contributing to the inertia and the frequency of the power system. But we have to think of on that also because in future power system, now there is a replacement of these conventional motor with a variable frequency drives and another non-rotating electronics devices. Because of that, the contribution of the inertia by the load will also reduce. Now presently around 10 to 15% contribution of inertia from the load side also. But in future grid, replacement of these conventional motors by other devices like variable frequency drives and non-rotating electronics device will reduce the inertia of the system. So now the role of in accurate estimation of inertia is also important, and system operator and policy maker and researcher may develop a suitable method to determine the inertia in the future grid. But in the future, this power system becoming a inverter dominated power system. So the inertia requirement will become a tradable commodity, and hence generating units may demand some financial compensation. Thank you. This is from my side.
Thank you so much, Mr. Modi, for sharing your views.